I now have the pleasure of introducing our first speaker. Our first speaker will be Miller, assistant professor in the Department of Environmental Health and Engineering at the Whiting School. His research group studies the emissions of greenhouse gases and air pollutants. And today, as you can see on his slide, he'll be giving a talk titled Tracking Greenhouse Gas Emissions in Baltimore and Across the Globe. So please take it away, Scott.
That sounds great. Thanks, Susanna. So it's great to get a chance to speak in the SLC Symposium and to meet people I haven't necessarily met before. And today I want to give a little bit of an overview about the work that we're doing in my group on tracking greenhouse gas emissions, both in Baltimore and across the globe. So, next slide. Let's see. Great. So a little bit of context before I get rolling here. There are really large uncertainties in what we know about emissions. And, in our group, we've done a lot of work specifically in looking, for example, at methane emissions. Methane is a really important greenhouse gas. And here are two really clear examples of how there's just a lot of knowledge that we're missing in terms of emissions. So first of all, we really don't know a lot about, how much greenhouse gases or methane could be coming from thawing permafrost as one clear example. And on the right-hand side here in this figure shows an example of different model estimates of methane emissions from thawing permafrost and from wetlands. The top panel here shows the mean of a bunch of different models, and the bottom panel shows the range of all of these models. And if you look at this figure, the range is bigger than the mean. In other words, what we don't know about methane emissions from thawing permafrost and from wetlands is bigger than what we do know. And our understanding of human-caused emissions is no better. For example, in 2014, the EPA Inspector General's Office published a relatively critical report saying that EPA's emissions estimates of emissions from the natural gas sector in the United States may not be valid, are the precise words that the Inspector General used. And they pointed out that EPA is using data that was last collected in the 1980s in collaboration with the natural gas industry. And there are some real questions about whether data collected in the 1980s is still valid to describe the natural gas sector today. Next slide. So that brings up a really important question of how do we track emissions? Well, there are two different approaches that different people tend to use for estimating emissions, and one is called a bottom-up approach, and this is what the Environmental Protection Agency and other government agencies use. So it's an accounting type of approach to track emissions. For example, you might count up the total number of coal mines in the United States and then try to estimate the average emissions per ton of coal and multiply those two numbers together. Or another example, cows burp a lot of methane. So you might want to try to count up the number of cows in the United States and then multiply that by the average burp rate per cow. But a challenge with this approach is that sometimes it can be easy to overlook things, overlook misbehaving actors that aren't doing what they've said that they're doing. Or, maybe that there's something that you forgot to count. And so as a result, a lot of these government agency inventories sometimes tend to be an underestimate or an undercount of emissions. By contrast, the approach that we use is called a top-down approach. So we measure greenhouse gases in the Earth's atmosphere and then use that to try to understand emissions at the Earth's surface. And the upside of this approach is that these emissions have nowhere to hide. If natural gas company is misbehaving and spewing lots of greenhouse gases into the atmosphere, we're going to see it with an airplane or we're going to see it with a satellite. And so that's sort of, I think, kind of an important role that we can play for helping to improve government estimates of these different greenhouse gas emissions. Next slide. So we've been focusing on a number of different areas, and I just want to give a really quick overview. First of all, one question we're really interested in is, are countries accurately reporting their total emissions? And one thing that we found is that the US underestimates its non-CO2 greenhouse gas emissions by about a factor of 3, both for methane and for nitrous oxide, which are the second and third most important greenhouse gases out there. Next slide. We also are really interested in understanding what fraction of emissions are human-caused versus natural. For example, we don't see any signs that thawing permafrost is going to overtake human-caused emissions anytime soon. Next slide. And we also want to understand how are emissions changing over time. So one example, over the past decade, the US has had a huge natural gas boom that's coincided with the rise of hydraulic fracturing or fracking. But we don't see any change in methane emissions across the United States, and we're trying to understand why. Also, we found that China in particular is not meeting its methane emissions targets, something that hasn't necessarily come to light without this top-down approach using atmospheric observations. Next slide. And lastly, we're really interested in leveraging new big data on greenhouse gases from satellites. When I started my PhD, there were only about 4 greenhouse gas measurement sites across the continental United States, and a really, really small amount of data for a really huge country. Now, within the past couple of years, we have new satellites that measure these greenhouse gases from space and collect millions and millions of observations per day. So the community, I think, is really struggling to wrangle and figure out how do we use these millions of observations to learn the most that we can about greenhouse gas emissions across the US and across the world. Next slide. And just one example that I want to highlight here, one thing that we found is that human emissions seem to play a much, much larger role in greenhouse gas emissions of methane, particularly from the US and Canada. So here are bottom-up estimates from the EPA and Environment Canada of US and Canadian methane emissions. So in this plot, you can see that natural gas and petroleum industry play an important role, and so does agriculture. But on this plot, you can see the biggest contributor, according to these bottom-up estimates, are methane emissions from wetlands. So if you were to look at this plot, you'd say, you know, these natural sources are really dominating our methane emissions, and human emissions really aren't that big of a deal. Next slide. But then when we use this top-down approach, what we see is completely and totally different. So here are estimates that we've come up with using this sort of top-down approach for different regions of the US and Canada. So the left bar here shows human-caused emissions from the US. Then moving toward the right, you can see our estimate for total methane emissions from Canada. In the middle, you can see our estimate of methane emissions just for the states of Texas, Oklahoma, and Kansas. And the reason why those 3 states are really important is because there are a lot of natural gas wells there that are leaking methane, and there are a lot of cows in Texas, Oklahoma, and Kansas that are burping methane. And then the right 2 bars show methane emissions that we estimated for several wetland regions, for wetlands in Alaska, and then also a big wetland region in Canada known as the Hudson Bay lowlands. And what you can see is that methane emissions from these wetland regions are really pretty small. And they're much, much smaller than anthropogenic emissions from places like Texas and Oklahoma, or from anthropogenic emissions from the United States. So if you were to look at bottom-up emissions estimates, you might think that, you know, these emissions are really being caused by natural sources. But when we look at atmospheric observations, what we really find is the opposite, that most of our methane emissions from the United States and Canada are being caused by us, by humans, and they're not the result of natural processes. Next slide. And then the last thing I wanted to highlight are some work that we're doing here right at home in the city of Baltimore. So we're working with the Baltimore Office of Sustainability in order to track the city's greenhouse gas emissions and understand whether Baltimore City has met its greenhouse gas emissions goals. And we think so far that either the city has met its emissions goals or is coming pretty close. But there's sort of an interesting explanation or an interesting caveat for that. Baltimore's emissions are really decreasing not because we've changed our lifestyles or are buying more fuel-efficient cars. Rather, the city's emissions are changing largely because of the natural gas boom, largely because of the rise of hydraulic fracturing in places like Pennsylvania. 10 years ago, Baltimore got most of its electricity from coal, and now we get most of our electricity from natural gas thanks to the hydraulic fracturing boom because gas prices have gone down so much. And natural gas produces less in terms of greenhouse gas emissions per kilowatt hour of energy produced. And so as a result of that, the city's emissions are really decreasing, not necessarily because of actions we're taking, but because of good luck in the sense that our energy mix has changed over time. So with that, thanks again for having me, and it's great to be able to share the research our group is doing with everyone here.
Okay, well, thank you so much, Scott. So very interesting stuff. So if there's any questions from the audience, please enter them in the Q&A window and we'll get to you. And maybe while we wait for the audience to do that, I'll ask you a question, Scott. which is, it's clear that you're using this really interesting and sort of granular data to make these estimates. And I'm curious, where does this data come from? Is it some kind of international collaboration, or are these publicly accessible data sets? Where does the data come from?
Yeah, so all these data sets are publicly accessible. For example, these new greenhouse gas satellites are mostly being launched by NASA and by the European Space Agency. And then the sort of ground-based greenhouse gas monitoring network in the US is the NOAA, the National Oceanic and Atmospheric Administration, is in charge of that. So it's great that all of this data is public and that in theory, anyone can go online. And a lot of this data, in fact, now is in Google Earth Engine. So if you've ever used that platform before, you can just go on Google and map methane data across the world.
Great, thanks. And so we do have an audience question. So the question is, do the BGE emissions decreases that you describe account for leakage of methane upstream?
Yeah, so that's a really good question. The answer is that the BGE estimates do not account for leakage of methane upstream. So there's been a lot of work in the scientific community recently that it turns out that leaks from natural gas infrastructure are much, much bigger than we would have otherwise thought. And so interestingly, if you don't account for methane leakage from the natural gas industry, it looks like Baltimore City probably is meeting its greenhouse gas emissions targets. But the minute you start accounting for methane leakage from leaky gas pipes or from leaky natural gas infrastructure, those reductions and those gains really start to vanish. So that's sort of an interesting caveat, I think. Most cities at the moment, to my knowledge, aren't really accounting for this leakage in their greenhouse gas emissions estimates, but it's something that we really want to do.
Great. Okay, so we're running low on time, so I'm going to ask one more question, and then perhaps, Scott, you might be able to use the chat function to answer the other questions within the Q&A text feature. So the next question is, when you say the city of Baltimore emissions, do you mean all businesses, transport, and residences in the city, or just the city government energy use?
Yeah, that's also a really great question. Here we're referring to all businesses, transportation, and residences. And we're also referring to what we call Scope 2 emissions, which are emissions caused by electricity demand in the city. So this includes, for example, coal that might be burned in West Virginia in order to power electricity within Baltimore City. So it includes, emissions from the car that you drive, emissions from your house, and then also emissions due to the electricity demand that we create, where those power plants might be out of the city limits.
Okay, great. Well, thanks again, Scott. And so I think what we're going to do is turn it over to Irina, who's going to introduce our next speaker.